our notes and your assignment today is going to be over probability. We have a definition. Probability is the likelihood a given event will occur. Probability of an event can be found using the following equation. So what it means by the likelihood of an event occurring is what are the chances of something happening? And when we need to figure out the chances of something happening, we have to think about how many possible things could happen versus what we want to get out of the event. Um, so if we look at the equation right here, P stands for, this P stands for probability. So we've just shortened the word probability and made a P to represent probability. And then in parentheses we have event. So what event is it that we are looking for? The probability of a certain event equals the number of favorable events. This is what we want to happen over the total number of total outcomes. Fractions, because this is just a fraction or a ratio, are always going to be part of something out of the whole thing. Okay? So P event, probability of an event, equals the number of favorable events over the number of total outcomes. We've got some examples here to work through. Erica rolls a 6-sided number cube. What is the probability that Erica rolls a 4? So if you look right here, we have P, and then in parentheses we have a 4, because we're wanting to see what is the probability, what is the likelihood that when she rolls that dice, that it will land with a 4 up. So we'll think about a dice for a second. It has 6 sides. Sides 1, 2, 3, 4, 5, and 6. There's 6 sides. And we want to know the probability that she's going to roll a 4. So I'm going to circle what we want her to roll. How many chances of rolling a 4 does she have? 1, because there's only 1 4 out of the whole die, over the total number of outcomes. 1, 2, 3, 4, 5, 6. So there are 6 total outcomes. So the probability that Erica will roll a 4 is a 1 out of 6 chance. We also have this word called the complement. The complement of an event includes all outcomes that are not the desired outcome. Okay, desired here is talking about favorable. Okay, favorable, so not the favorable outcome. So what is the probability of the complement of Erica's roll above? So Erica's roll above was she wanted to roll a 4. Well, let's say that she does not, the probability that she does not roll a 4. I'm going to list out the sides of our dice. 1, 2, 3, or a die, excuse me, 4, 5, 6. We do not want to get a 4. So I'm going to mark that out. So we could get a 1, 2, 3, 5, or 6. Those are the favorable. We don't want to get a 4, so we're not going to include that in our favorable event. Okay, so that means that we have a 1, 2, 3, 4, 5 favorable out of our total, which is 1, 2, 3, 4, 5, 6. Okay, so the probability of not rolling a 4 is 5 out of 6, because there's 5 other things that she could roll. Now, one thing I do want you to notice, if we take the probability of her rolling a 4, 1/6, and the probability of her not rolling a 4, 5/6, that is going to equal 6 over 6. And that's because if she has the probability of rolling a 4 and then the probability of not rolling a 4. That includes the sum of the probability of her rolling a 4 and the sum of her not rolling a 4 is every single event that could happen. Okay, so the complement of a probability experiment and the probability experiment itself is going to equal a total of 1. So you can see that. On to our next example. Devin purchases a bag of candy-coated chocolates and discovers that out of 32 total chocolate candies, 11 are blue and 10 are orange. If Devin selects a chocolate candy at random, what is the probability that the candy will not be blue? So this one makes us think a little bit. If we go back to the equation for probability, we know that we want to have the number of favorable events, but we do not want to include the blue candies. And our favorable events is going to be set on top of the total number of outcomes. And if we look back at this problem, how many total candies are in the bag? It says that there are 32 total. So we're looking for the probability of not getting a blue, which means we are not going to include the blue candies. And our total is 32. So there are 32 candies in that bag. And if you look at the problem, it says that there 11 are blue, which we are not going to be including, and 10 are orange. Well, if we have 11 blue and 10 orange, we're missing some candy because 11 plus 10 is 21, and it's saying that we have 32 total candies. So we're going to add these together, which gives us a total of 21. And so we have to see how many other candies there are. So there's 32 total in the bag, minus the 21 orange and blue, which leaves us with 11 others. Okay, so we have 11, we know that there are 11 blue, we know that there are 10 orange, and we know that 11 of the chocolate candy is something other than blue and orange. So we go back to our probability. We do not want a blue, so there's 11 blue, 10 orange, and 11 others. So we want to add together the 10 orange and the 11 others, which equals 21. So 21 out of 32. And we cannot simplify 21 over 32, so we're going to leave the probability of not getting a blue is 21 out of 32. So there's a pretty good chance that we would not draw a blue candy out of that candy sack. Okay, on to our next problem. This one's going to change things up just a little bit, so make sure that you're still listening and paying attention. Ryan tossed and rolled a number cube. So he tossed and rolled a number cube labeled 1 through 6. What is the probability of tossing tails and rolling an odd number? So our probability is an odd number and tails. Okay, we're looking for the probability that he rolls an odd number and gets tails. When we see that and, we're going to have to multiply our two probabilities together. So we're going to find the probability or the likelihood of him getting an odd, and then we're going to find the probability of him flipping tails, and then we have to multiply those two fractions together. Okay, so the probability of him rolling an odd on the number cube is 1, 2, 3, 4, 5, 6. And we're looking for an odd number. So our odd numbers, I'm going to circle them. 1, 3, and 5. So there are 3 odd numbers out of 1, 2, 3, 4, 5, 6 total. And that can be simplified. 3/6 can be simplified. We can divide by 3 to reduce this fraction, which is 1/2. So the probability of him rolling an odd number is 1/2. Okay? Now we need to find the probability of him flipping tails. So there's two sides to a coin. So there's one tail out of two sides total. So the probability of getting an odd number is 1/2, and the probability of flipping tails is also 1/2. And I said when you have two things, when you're looking for odd and tails, you're going to multiply those two fractions together. So we need to multiply 1/2 times 1/2. Now we have to remember how to multiply fractions. It's super easy. We're going to do 1 times 1, which equals 1. 2 times 2, which equals 4. So this is the probability, 1/4 probability of him rolling an odd number on the dice and flipping tails. So just to remember, we had to find the probability of him getting an odd number and the probability of him flipping tails, and we multiplied those two fractions or probabilities together. Okay, last example. Sasha spins the spinner shown below. If Sasha spins the spinner once, what is the probability it will land on E or G? So our probability is that we want to land on E or G. Since we have the word or, we're going to add those two things together. That's a little different from the previous example. With the word and, we multiplied. But we had the word or, so we're going to add the two things together. So we need to first look at how many E's and G's there are on the spinner. We have an E right here, and we have a G right here. So how many E's and G's are there all together? There are 2. Okay, so favorable over the total, we have 1, 2, 3, 4, 5, 6, 7, 8 different spaces that we could land on. We want to land on 2 out of those 8. We need to simplify this fraction to 8ths. And since they're both even numbers, a really good place to start is to divide them both by 2. Okay, so we can divide 2 by 2, which equals 1. And we divide 8 by 2, which equals 4. So the probability of rolling an E or a G is 1/4. Now you're going to tape these into your journals, and you can title it probability and leave these out on your desk, so while you're working through your assignment, you can go back to your probability notes. Also, you'll be able to go back to your sample space notes from yesterday and your dot plot notes and your box and whisker plots. So after you've got all that stuff in your journal and leave your journal out, you're going to click next at the bottom right of the screen, and it will take you to your assignment for today.